Hi everybody, it's Miss Kim. I wanted to give you a video to go over this chapter 10 review. Number 1, we are looking at vocabulary. Tell whether NM is best described as a radius, chord, diameter, secant, or tangent of circle P. So first let's identify the segment that they're talking about here. NM looks like it is this line. That one intersects this circle twice, which means it is a secant line. Tell whether Kn is best described as, okay, where's Kn? Here's Kn. This one is the diameter because it is a chord going through the center. Remember, chord means it has it's a segment with endpoints on the circle. Tell whether Pn is best described as a radius, chord, diameter, secant, or tangent of P. Okay, here's P, here's N. So this is a radius. It's half the diameter. It's also a segment from the center from the center to the circle. Number 4, tell whether the common tangent is internal or external. So the way we tell is we connect the centers, and if this tangent line that touches both circles once does not cross it, it is external. Does not cross the segments connecting the centers. Next one, number 5, points Y and Z are points of tangency. Find the value of C. Okay, so C's our variable. Points of tangency means it touches the circle once. They're both coming from the same endpoint, so we learned these are equal. So we set those equal to each other. Now, since we have a C squared and a C term, this reminds us we have a quadratic. Remember, this is how we solve when it's quadratic. So let's go ahead and put it in standard form. We'll subtract 9C and 14 from both sides. Oh, look, our C term goes away. 6 minus 14 is negative 8. Oh, well, that's interesting. Okay, so you'll notice we just eliminated our middle term because we had that positive 9C and negative 9C. So now we're just down to solving for C squared. So when that's the case, we're going to solve with square roots. So let's go ahead and add the 8 back to the other side. We'll divide by 2 so we can get C squared by itself. Now we can take the square root. So it's positive and negative 2. So in geometry, anytime we have a negative as a variable, we have to substitute it to test and see whether it'll work as an answer. So if we substitute it here, for example, we'll get negative 18 plus 14. That's negative 4, and we can't have negative distance. So we'll throw away the negative 2 and we'll report just the positive 2 for the answer. Next, tell whether AB is tangent to circle C. So if it's tangent, remember one definition is it touches the circle once. The other definition is that it is perpendicular to the radius. So if that is perpendicular, then we have a right triangle formed that should satisfy the Pythagorean theorem. So we test it to see if it's true. So looking at our triangle, 10 is the radius, So we have to make sure we add another 10 to get the short side of the triangle. So we'll sub 20 squared plus 48 squared and set that equal to 52 squared. So this will be 400, and this comes out to 2304, and this comes out to 2704, and then when you add the left side, you can see the left and the right are equal, so yes, it's a right triangle, which means yes, it's tangent. Looking at our answer choices, it can't be this one, can't be this one, and let's see. Here it is. It's because AB and CB are perpendicular at point B. Yeah, here's AB, the long leg, CB, the short leg, they're perpendicular at point B. Next slide. Use the diagram to find the measure of LM. Here's LM. So that's going to be congruent with the central angle right there. And we just need to figure out what that is. Okay, so if we notice, we've got a diameter here that goes through the center, which means we have 180 degrees. If we subtract this 100 that's here, it means we've got 80 here. And if we subtract this 120, it means we have 60 right here. So this one has to be 60 degrees. Okay, let's do it here. We're looking for arc KN, which will go with this central angle. All right, so again, we've got a diameter. Anytime you have a diameter, you can just subtract from 180. That would give this one 80, this one 60. So this arc is 80 degrees. Okay, tell whether the red arcs are congruent. Explain why or why not. All right, this part's really important. You'll notice, if you need to take these circles apart, you can. This is circle C, this is circle D. So they all have this radius that they're showing, and then this 95-degree angle. And so here, circle C also goes like this with 2 more radii drawn. All right, so then we're looking at this red arc and this red arc. Now, you'll notice this 6 is labeled here and here. That's the radius, so all these radii are all congruent. And so what that means is that our circles are congruent, and that means our arcs are congruent. They do have the same central angle measure. They are in congruent circles because the radii are congruent, so you know your circles are congruent. Find the measure of arc AB. I'm going to zoom in a little bit here so these pictures are slightly larger. There we go. So arc AB is this one. And this is our perpendicular chord bisector theorem. We have a diameter perpendicular to a chord, which if this is marked congruent, that means it's been bisected, so we know this is a diameter going through the center, and it also bisects these chords, so we know that this is also 65 degrees. So the chord and arcs, or the chord and arc are bisected, cut in half. On the next one, QN and QP are both equal to 10. We can see those are marked equal. So that's this segment and this one. JK is 4x, that's already marked, and LM is 6x minus 24, that one's marked too. Find the radius. So this is one of those where we're going to have to draw the radius in. So we'll solve for x first by setting these equal. We know that because it's the equidistant chords theorem. All right, if those chords, JK and ML, are equidistant from the center, which they are, then we know that they're equal. So we'll set them equal, divide by -2 on both sides, and we get 12. So if we plug in a 12, we get 48 here, 48 here. That means each half is 24. Okay, so I'm going to build my right triangle down here. So that half is 24. Now I'm going to use red, and I'm going to draw my radius from Q to L. So I'm creating this right triangle. I'm going to make it a little bigger out to the side. This is my radius. So I will just plug that into Pythagorean theorem. That is 676, and we take the square root and we get 26. Okay, on this one we're finding the values of Q and R. This is an inscribed quadrilateral. All the vertices are on the circle. We learned that each angle is half of its arc. We also learned if it's a quadrilateral that opposite angles are supplementary, so they add up to 180. So we can just add each pair and set them equal to 180. So Q plus 80 is 180. 4R plus 100 is 180. From there, we can go ahead and solve. So we get 100 for Q. We'll subtract 100 first from both sides. Whoops. And then divide 4. R is 20. Moving on to the next one. We also have vertices on the circle, so these are also inscribed. It's half of its intercepted arc. So this arc is 180 since QN is the diameter. So we'll say 3y is equal to 1/2 of 180. Which is 90. We'll divide by 3, so y equals 30. And then to find z, let's use a different color. Z is associated with this angle Q, which intercepts this arc, PN. Now we notice QN is a diameter, so again, this cuts the circle in half. If we know angle N is 50, then we know this arc has to be 100 because it's times 2. And then this has to be 80 because those have to add up to equal 180. So we can set 4z equal to 80. Oh, not 80, sorry, half of 80. Half because it's an inscribed angle, right? 4z is the angle, it's half of its intercepted arc. Half of 80 is 40. Divided by 4 is 10. Find the value of angle C. So here we look at where is the vertex. It is on the circle. That means it's inscribed. And the angle is half the arc. So C is half of 56. Half of 56 is 28 degrees. Find the value of x. Now where's the vertex? In the circle. The angle is equal to half the sum of the arcs. Now which arcs? The arcs that it intercepts. So like this, 152 and 60. So x is equal to 1/2 152 plus 60, which is 212. Half of that is 106. Line L is tangent to the circle. That means it touches once here at Z. It's also an inscribed angle since the vertex is on the circle. It's going to be equal to half of the arc. So which arc are we looking for? X, Y, Z goes like this. And if we trace angle Z, we can see that is the arc that it intercepts. So 120 is the angle. That's half of the arc, which we'll call X. We'll multiply by 2 on both sides. And we get 240 degrees for the arc. Looking at the next one. Okay, so we'll notice these are measuring segments, not angles. So we're going to use the two chords theorem, which is each part of a chord times the other part is equal to the other chord part times part. So we'll distribute on the left and the right. We do have a quadratic, but we do have x squared on both sides. Let's see what happens when we combine things. Yes, we will end up with a quadratic here. So this would be minus 9x. Okay, so this time we have an x term and an x squared term. We don't have a constant, so what we'll do is we'll factor out the greatest common factor, which is 3x. That divides into x minus 3. Right? Going backwards, if you distributed, you're going to be right back there. Okay? And then since you have two factors equal to 0, we set them each equal to 0. We get two answers. Remember, we can't substitute a 0 as a length, so we're going to throw that one away, and our answer will be number 3. Okay, a local park has a circular ice skating rink. You're standing at point A, about 12 feet from the edge of the rink. The distance from you to a point of tangency on the rink is about 20 feet. Estimate the radius of the rink. Round your answer to the nearest tenth. Okay, so remember, a tangent line touches the circle once. The secant line touches the circle twice. Our formula is tangent squared equals external secant times the entire secant. So we'll substitute 20 for the tangent, 12 for the external secant, 12 plus r for the entire secant. Remember, you got to add everything that you've got. Also, remember, you know this, the diameter is equal to 2 times r, 2 times the radius. So when we simplify, we're going to get 12 plus 2r inside of that quantity. All right, then we just distribute. We'll subtract 144. and then divide by 24. So R is approximately 10.7 feet. Sorry, feet. Okay, next one. Write the standard equation of the circle shown. All right, so what's our equation? Here it is again. Remember H and K give you your center of the circle. R is the radius. Also remember, because there's a negative in front of the H and the K, they're always the opposite sign of what they look like. So our center is at, let's see, we're counting by twos here. So our center is at 8, 6. All right, so 8 is our H, K is our 6, and our radius is 2, 4, 6. So if we sub into the formula, it looks like that. And finally, when we square the radius, here's our equation, which is this selection right here. All right, let's go backwards. Write the standard equation of the circle with the center at 0, 0. So that's our H and K, radius 9. So that's just going to be x minus 0 squared plus y minus 0 squared equals 9 squared. And then when we simplify that, here's our equation. All right, we're almost done, you guys. Let's do this again. So this is our HK, this is our R. So we're going to go x minus 6 squared plus y minus 21 squared equals 4 squared. I want you to show the substitution first, and then your final answer. All right, so all you're doing is subbing H, K, and R. Let's do it again. Okay, hopefully this is getting a little easier for you guys. And here they gave us one with a negative, so that's good. We need to practice doing that too. Oh, we don't know the R. Okay, so we have to find R here. So they gave us, oh, I see, this is the center, so this should be a 6. Our H is negative 7, our K is 6. Okay, so what they've given us here is a center and a point on the circle. Let me draw this a little better. Let's go like this. Okay, so if my center's at negative 7, 6, let's say it's up here, and then negative 7, 1 is on the circle, so it's something like that. I know that's not a perfect circle, but hopefully you get the point. All right, so we got to find that radius. I'm just going to use distance formula between my 2 points. So I'm going to go 6 minus 1 squared, negative 7 plus 7 squared. Okay, so my radius looks like it's a 5. Okay, so hopefully you followed that. We subbed for H, which is our center, K, which is the Y of our center, and then we found R, which is 5. All right, so the last step is to simplify that. It'd be x plus 7 squared plus y minus 6 squared equals 25. So it is the first one. All right, let's finish this up. Prove or disprove the statement. The point 4, -3 lies on the circle centered at the origin containing the point -5. Okay, so let's draw a picture and break this thing down. So we've got a circle centered at the origin containing the point -5, 0. Okay, so we know our R is 5. And then the point 4, -3 would be, let's see, 4, -3 would be like over here. So what they want us to do is figure out the distance here and see if that's also 5, right? If this radius is 5, the other one should also be 5. So let's do the distance formula again. So I'm going to go between 0, 0 and 4, -3. So we'll go square root of -3 minus 0 squared plus 4 minus 0 squared. So you should be able to see you got a 3, 4, 5 triangle already. I hope you can see that. All right, if you go like this and this is 3, this is 4. Our radius is 5. So let's see, the radius of the circle is 5 units. We just found that. We also found it on our original graph. The distance from the point 4, -3 to the center of the circle is 5 units. So the point 4, -3 does lie on the circle. So this is a yes. I'm not sure what your options are, but that's a yes. All right, I hope that helped. Feel free to watch Mr. Smith's video too. He really focuses in on 10, 5, 6, and 7. And let me know what questions you have. Thanks for watching and listening. Have a great day.